Welcome to a lesson with Dr. Powell. Let's take a look at how a Taylor series can help us to integrate. This time, let's do cosine of square root of x. Now, it might be challenging to find an integral, an antiderivative of this, but let's look at a Taylor series. So Taylor series for this would be the regular one for cosine, but with square root of x plugged in. Now remember, the one for cosine is 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial minus and so forth. Well, if we were to plug in square root of x into this, it would look like 1 minus, replacing x with square root of x, 1 minus x over 2 factorial plus x squared over 4 factorial minus x cubed over 6 factorial and so forth. Now, if we took an antiderivative of this, we would have x minus x squared over 2 factorial plus x cubed over 3 times 4 factorial minus x to the fourth over 4 times 6 factorial and so forth. Okay, and we can evaluate from 0 to 1, and we'd end up getting 1 minus 1 over 2 factorial, or 2 times 2 factorial, plus 1 over 3 times 4 factorial, minus 1 over 4 times 6 factorial. So we have this series that we've just started, and the first few terms will tell us, the first few terms right here give us a good approximation for what the actual definite integral is, just by using this Taylor series. How far off are we by just using the first few terms? Well, notice that this series is alternating, so we can use an alternating series type test for our check for remainder. In fact, the next one over, let's see what that would be. Let's see, is there a pattern here? So these go 2, 3, 4. These are counting just by these first guys, 2, 3, 4. And then we have 2, 4, 6. So it looks like the next one will be 5 times 8 factorial. So if we just use these, let's start right there, going back this way. So the remainder is bounded by the absolute value of the first term in the remainder, which is that. So if we just use the first 4 terms to add, that's a good approximation because the remainder is less than that, which we could compute as what do we got? 8 times 7 times 6 times 5 times 4 times 3 times 2, and you also have times 5. So that would end up being, if you would multiply this out, it's a fairly decent size number. So we can kind of approximate it. So this is 6 and that's 4, so that's 24 times 5 is 120. So you got 120, and then over here, see, that's 40, and over here, that's 42. So notice we're getting a fairly decent size number. In fact, we end up getting what, 48. So if we do these two together, that's what, 48 with 2 zeros. Right, and that's times 42. So let's see, and we got 42 and 48, multiplying those together, that would give us 6 and 1 and 32 and 33 And then we have 4 and 2 is 8, and 4 and 4 is 16. So adding this up, it looks like we have 6, 1, 0, and then put another 1, so 2. So it looks like, wow, that's pretty good. The error is less than 1 over 2016. Amazingly good if we just use the first 4 terms. So we have approximated this integral by hand without too much difficulty, this definite integral. Thanks for watching.